our last example. In 6.1, the areas between curves, we looked at some good stuff. Just kind of about part A was, about as straightforward as you can get with these. Part B didn't give us those vertical lines. We had to find where each side, where those curves intersected to find the limits to put on our integral. In part C, we had a situation where the curves actually crossed each other. So we had to find two different areas. Part D, what's going on here? Let's take a look. Area between these, y squared equals 2x plus 4, and y equals negative x plus 2. Notice this is not a function. Interesting. Let's take a look at the graph. As we know, we can graph non-functions here in Desmos, no problem. Turns out that first one is a sideways parabola. And the second, y equals negative x plus 2, is this line that cuts down across the parabola. So here's our region. Again, we don't have any vertical lines, or, we're not told outright like where to start and stop our integral. So we've got this kind of thing happening. Here's where they intersect. Okay, let me graph that on paper. And we'll talk about how we're going to do this. So the parabola is doing this sort of thing. That's y squared equals 2x plus 4. And then that line, if you noticed, it crosses through this same point at 2, and it cuts down across. So kind of something like that. Y equals negative x plus 2. And there's the region. Okay. When we're looking at an area like this, notice that we cannot do it in the way that we've done the other ones. We cannot think, hey, where's the starting point on the left and where's the ending point on the right? Why is that? Because on the left, notice if we said, well, this is where we begin here, right? We're at -2. This is where it is on the graph. Can we go from here to here? Well, think about like top and bottom, right? For a while, the parabola acts as both the top and the bottom in this section. And that's an issue. We can't have the same function, right, be the top and the bottom. Here's what we need to do. Sort of tilt your head to the right and look at the image sideways. So when I'm doing that with my head, fortunately, I've got a camera here. We're not just on a whiteboard. I'm talking about rotate the image like this. Now it will work. If I think of it this way, here's the top function, and the entire parabola acts as the bottom. From there out to where these cross down here. Top, bottom. But now, of course, the way it's actually oriented is this way. We're thinking of this like the axes like being reversed. What I'm getting at is we're going to integrate with respect to y. We're not going to integrate with x. We're going to integrate with y. Because like I said, it's almost like we got to change the orientation of the axes. Okay. First thing, let's figure out where these intersect but we got to figure out the y value where they intersect, okay? Here we know they intersect at 2. Where did these cross on the y value? If you look back at the graph on Desmos, they cross at -4. And you could confirm that by plugging in y equals -4 into each and solving for x. If you put -4 in here, you'd get 16. Solving for x would be x equals 6. If you put -4 in there, subtract 2, a negative, x would equal 6. And they would cross. We don't need to note it, but they would cross at x equals 6. Okay. What else do we need to do besides note where these cross each other on the y-axis? We need to solve each equation for x. Originally, we think of the equations as solved for y, but we got to reverse it. So let's think about this first equation. We could think of it as y squared equals 2x plus 4, but we want to think of it as x equals. If we solve for x, what would happen? Subtract 4, divide by 2, it'd be 1/2 y squared minus 2. Okay, and here if we solve for x, add x, subtract y, 2 minus y. So it's the same functions, but just rethought. And now they're both functions, but they're functions of y instead of functions of x. Okay. Now we can go for it. The area, the integral. We're gonna move the integral on the y-axis this time. When you're on the y-axis, you always go bottom to top, right? X-axis, it's left to right. Y-axis, bottom to top. -4 to 2. The smaller number always on bottom, -4 to 2. When you set up the integral, now, if looking at it this way, which one would be the top, right? And when we rotated it, we realized, oh, that line is on top. It's always the function that's on the right, 2 minus y, minus the function that's on the left, 1/2 y squared minus 2, dy. The right minus the left. Why is it right minus left? Well, because if we think about switching the axes, these are the more positive, these are the more negative. So these are the ones on top. This is what's on top. This is the higher values. These are the lower values. So again, switching it this way, top minus bottom. And then as you set up your integrals, bottom to top, lower number to higher number. Again, right, takes a lot of work. In the end, let's kind of summarize. When we realize this situation, say, okay, we got to reverse the axes. So solve both equations for x instead. Identify where they cross on the y-axis. Set up your integral, and then think right minus left. From here, it's just a matter of cleaning things up and then doing your integral. So I'm going to put the -1/2 y squared first, highest power, then minus y. And then I've got 2 minus -2 is +4. Okay. Keep going. Antiderivative, -1/6 y to the third, minus 1/2 y squared plus 4y from -4 to 2. Continue down here. Plugging in, -1/6, 2 to the third, minus 1/2, 2 squared plus 4 times 2. minus -1/6 -4 cubed minus 1/2 -4 squared plus 4 times -4. So I'm going to do these each separately. A lot happening here. Do my first integral. This is 14/3. And -40/3. So adding them, 54/3 is actually a whole number, 18. Interesting. There you go. So yeah, again, take some getting used to when you have to switch what you're integrating with respect to. There you have it. Hey, that does it for 6.1 and finding areas between curves.